Okay, think about it. There are literally billions of pages on the internet. So how in the world does a search engine decide which ones are actually important? It really does feel like magic, but it's not. It's a beautiful, elegant algorithm that brought order to the absolute chaos of the early web. And today, we're going to pull back the curtain and see exactly how it works.
This was the big one. This was the fundamental challenge that early internet pioneers were up against. As the web just exploded in size, finding that one useful piece of information was like finding a needle in a global haystack. So how did they finally crack the code?
To really get why the solution was so brilliant, we first have to understand just how big the problem was. So let's take a quick trip back in time to the early days of the web, which honestly felt a little bit like the Wild West.
Yeah, in the original paper that actually described Google, the founders talked about this exact issue. Sure, search engines existed, but they would often just spit back a flood of totally irrelevant, low-quality junk. As they put it, these junk results just drowned out anything useful. The web was huge, but it wasn't smart. Not yet, anyway.
And then, out of a research project at Stanford, came this profoundly simple idea that changed everything. An idea that treated the entire web like one giant, ongoing election. That idea was called PageRank.
The core concept here is just deceptively simple. It's not just about how many links a page gets. No, it's about the quality of those links. See, a link from a really respected page, say a major news site, acts like a much more powerful vote than a link from some random obscure blog. It creates this recursive, self-reinforcing system of authority.
And look, this isn't just my interpretation. This quote is straight from Google's own philosophy. They saw the web's link structure as this massive election. Every single link is a vote that's basically saying, hey, check this out. This page right here is a valuable source of information.
So how does this whole voting system work in practice? Well, the creators came up with this fantastic analogy, the random surfer. Picture this, someone just browsing the web, clicking on links totally at random. The pages that are more important, the ones with all the high-quality votes, are the ones our random surfer is statistically way more likely to land on. A page's rank is literally just the probability that our surfer is on that page at any given moment.
But wait, what if our surfer gets stuck in a loop of pages, or just hits a dead end with no links? Well, that's where this number, the damping factor, comes in. It basically means there's an 85% chance the surfer will click a link on the current page, but a 15% chance they just get bored and teleport to a completely new, random page on the internet. It's this one crucial feature that keeps the surfer from getting trapped and makes sure the entire web can be ranked.
Now, PageRank wasn't the only game in town. There was this competing algorithm called HITS that saw the web a little differently. Instead of one single important score, it said pages have two distinct roles. You've got your authorities, which are the pages with the actual valuable information, and then you have hubs, which are pages that are really good at linking to those authorities. Think of an authority as a landmark scientific paper, and a hub as the awesome bibliography that points you right to it.
So the big question is, do these two systems agree on what's important? Well, the answer is pretty fascinating. It totally depends on the neighborhood you're in. On the messy, chaotic, general web, the data shows they almost completely disagree. But in a highly structured place, like an academic network where every citation is deliberate, they are nearly in perfect agreement. And that tells us something huge. The very structure of a network fundamentally changes what importance even means.
The success of PageRank didn't just organize the web. It accidentally created a multi-billion-dollar industry dedicated to trying to understand and, well, influence it. I'm talking about search engine optimization, or SEO. And for years, the central debate in that entire industry has been all about links.
So, let's start with the official line, straight from Google. A top analyst there recently said that over the years, the company has actively been working to make links less important in their algorithm. Okay, interesting.
But then, you look at the data from the people who study this stuff for a living. Major SEO platforms consistently find this incredibly powerful connection. Ahrefs sees a direct correlation between more sites linking to you and higher rankings. Backlinko found the #1 result has, on average, almost 4 times more backlinks than the rest of the top 10. So, what is going on here?
And this really gets us to the core tension in the modern SEO world. You've got Google on one side saying one thing, and then you have a mountain of industry data that seems to be saying the exact opposite. So, who are we supposed to believe?
The answer, well, it lies in this classic statistical puzzle. It's the ultimate chicken or the egg problem.
Does getting a ton of high-quality links cause a page to rank number one? Or does a page rank number one because it's just got amazing content, which in turn causes it to naturally pick up a bunch of links? For more than a decade, that question has been at the very heart of the SEO debate.
And just when we thought that whole debate couldn't possibly get any more complicated, a brand new player has entered the field, and it is changing all the rules all over again. I'm talking about artificial intelligence.
Let's think about it this way. Traditional search is like an algorithmic fortress. It's been hardened by decades of fighting link spam. But these new AI systems, they're more like a wide-open field. They can give you these incredibly rich, complex answers, but their underlying ability to judge a source is, for now, much more naive. They just haven't built up the same defenses. At least, not yet.
And this right here is the critical point for the future of the web. All of those old-school spammy link-building tricks that Google spent years learning how to ignore and penalize, well, they might just get a second life. These newer, simpler AI systems could be totally vulnerable to the exact same manipulation that traditional search engines already figured out how to solve. It's like the game is starting all over again.
This is leading to a whole new strategy called co-citation. The basic idea is that for an AI, just being mentioned near an authority source is almost as good as getting a direct link. So, for example, if a major medical journal talks about a new study and your health startup gets mentioned in the same article, even with no link at all, the AI learns to associate your brand with that authority. It's all about context becoming the new vote. It's PageRank's core idea, just adapted for an AI world.
And all of this leaves us with a really fascinating and honestly a slightly unnerving question for the future. As these incredibly powerful AI models crawl the web, learning from all the links and citations we've created, what are we actually teaching them? Are we teaching them how to spot genuine, hard-won authority? Or are we just teaching them to recognize the cleverest new ways to game the system? The next chapter of How We Order the Web is literally being written right now.